Hi everyone. So now it is the continuation of numericals in uniform flow. That is today's session. It's all about the problems on most economical cross section. That too for problems on most economical rectangular cross section. A rectangular channel of width 4 meter is having a bed slope of 1 in 1500. Find the maximum discharge through a channel. Assume Church's constant C is equal to 50. So there is a rectangle cross section which is having the width is 4 and the depth is 2. So now it is for most economical rectangular cross section we have to find out what is the maximum discharge. So we have the Church's formula Q is equal to AC into square root of Mi, but they are given only the width and the bed slope is given, but we have to calculate what is the depth. The depth is not given. So we can see in the given data B is equal to 4, I is equal to 1 in 1500, C is 50. So to find out the depth, we have the condition for rectangular cross section in most economical channel. That is B is equal to 2D. That's why I told you D is 2 meter because the width is 4 and the depth will become half of that. We have the condition B is equal to 2D, and if we are having B is 4 and B is equal to 2D, that is 4 is equal to 2D, then D is equal to 4 by 2. That is depth of flow is 2 meter. And also we have M, that is hydraulic mean depth. M is equal to D by 2. There are two conditions. One is B is equal to 2D, other one is M is equal to D by 2. So we have the depth is 2, then D by 2 is 1. So directly we can substitute in the area. Area is equal to B into D, that is 4 into 2, 8 meters square. Then we can substitute Q max. And remember it, sometimes they are going to mention it will be the economical channel, or if it is not specified, then when they're asking for maximum conditions or maximum discharge, in open channel flow, if they're asking to find out the discharge, it is you can use Church's formula and directly we can find out. But if they are specifying maximums conditions, maximum discharge, then it is for most economical section. So Q maximum is equal to AC into square root of Mi. A is area, that is B into D, that is 4 into 2, 8 meters square, into C is given 50. Then square root of Mi. M is D by 2, that is M is equal to 1. Then I is 1 in 1500. Then you will get the discharges 10.327 Qmax or 10.327 meter cube per second. Then the 12th numerical, a rectangular channel carries water at the rate of 400 LPS. LPS is liter per second. When the bed slope is 1 in 2000, find the most economical dimensions of the channel. If C is equal to 50. See, in the previous numerical, width is given, but we have to find out what is the maximum discharge. Here the maximum discharge is given, but we have to find out the most economical dimensions are B and D. So to find out that, we have to write the sketch and we have to write down the given data. Q is given as 400 LPS. So we know that 1 meter cube is equal to 1000 liters. So if it is 400 liters, then it is 0.40 meter cube. That is 400 by 1000. So Q is equal to 0.40 meter cube per second. Then I is given 1 in 2000. C is given 50. Then let B and D are the dimensions of most economical dimensions of the channel. Then we have the conditions to be remembered. If it is rectangular, most economical condition, the first one is B is equal to 2D, second one is M is equal to D by 2. Then area is equal to B into D. Then we have B is equal to 2D, then substitute that 2D into D, then area is 2D square. Then just substitute that directly in the discharge equation. Q is equal to AC into square root of Mi. Q is 0.40, area is in terms of D, 2D square, into C is 50 is given, so into 50 into square root of M is equal to D by 2, we can write that will be as 0.5 into D into 1, I is given 1 by 2000. Then we can see here 2D square, D to the power of 2, and here it is square root of 0.5 into D. So if it is square root of D, the power will become 1 by 2. So 1 by 2 is nothing but 0.5. Then we can kept the unknown is only D to the other side, that is D to the power of 2 plus 0.5 is 2.5. Then the remaining to the other side. So D to the power of 2.5 is 0.2529. Then if you are having 2.5 is here, if you are sending to the other side, it will become 1 by 2.5. Then you will get D is 0.577 meters. So once you find out D, we have the condition B is equal to 2D. Then we will get B is 1.154 meters. So depth is 0.577 meters. Then the width is 1.154 meters. So these two are the dimensions. And the third one, A rectangular channel of 4 meter, that is 13 problem, that is the third numerical when it is belongs to most economical rectangular cross section. A rectangular channel is having 4 meter wide, has a depth of 1.5 meter. The slope of the bed is given as in the channel is 1 in 1000 and the value of Church's constant is 55. It is desired to increase the discharge. Remember it here, the not specified, it is a most economical cross section, but the condition is they are specifying in terms of increasing the discharge to a maximum by changing the dimension of a section for a constant area and the slope of bed and the roughness of the channel. Find the new dimensions of the channel and if it is increasing the discharge. So initially the depth is given and the width is given, that is the B is 4 and D is 1.5. So the slope of the bed of the channel is 1 in 1000 and the value of constant is 55. It is desired to increase the discharge for maximum. So when the discharge is changing for maximum condition, then what will be the dimensions? So of course what you are having the discharge initially, definitely that will change when the dimensions are changing. So initial condition, the first case, B is equal to 4 meter and D is 1.5, I is 1 by 1000, C is 55. Then we can directly substitute. Area is B into D, that is 4 into 1.5 as 6 meters square. Perimeter is B plus 2D, that is P is equal to B is 4 plus 2D is 1.5 plus 1.5, that again you'll get 7 meter. Then M is equal to A by P, that is 6 by 7, 0.8571 meters. Then directly discharge equation, Q is equal to AC into square root of MI. Area is 6 meters square, C is 55. Then square root of M is, we have calculated 0.8571 into 1 by 1000. You will get discharges 9.66 meter cube per second. This is only for the first case. Then now, for maximum discharge, the dimensions are altered without changing the value of I and C as well as area. Let, instead of B and D, right, it will be as B dash and D dash or be the new dimensions. So when B and D are changed as B dash and D dash, of course the discharge will change. But area is to be same. They are saying area is 6 meters square itself. Then we can substitute A is equal to B dash into D dash. That is we have the condition for most economical. B is equal to 2D, that is B dash is equal to 2D dash, that is 2D dash into D dash or 2D dash whole square. Then area is 6, so 6 is equal to 2D dash square, then D dash is 1.732 meters. Then B dash will become 3.464 meters. So we can see the previous one, width is 4 but the depth is 1.5. Now if it is for the same area, for the same change, when the B and D has been changed with respect to most economical condition, when the discharge has been changed, then D dash is 1.732 instead of 1.5 and B instead of 4, it will become B dash as 3.464 meters. Then M is equal to D dash by 2, that is 1.732 by 2, so it will become 0.866 meters instead of 0.857. So now discharge is Q dash instead of Q. AC into square root of MI, 6 into 55 into square root of 0.866 into 1 by 1000. So this will become 9.711. So previous it is 9.66. Now if we are saying for maximum, this will become 9.711. Then what is the increase in the discharge? That is Q dash minus Q. Q dash is 9.711 minus 9.66. Then you will get 0.051 meter cube per second will be as the increased discharge. And the new dimensions are B dash is 3.464 and D dash is 1.732 meters. So these are all the three different numericals when it is belongs to most economical rectangular cross sections. So these are all the different ways when they're asking for most economical rectangular cross section. In the next session, we can discuss with other different cross sections. Thank you.